All right, guys, welcome to this page of the notes, and what we're going to do here is we're going to take a look at the last factoring method that we want to sort of introduce you to here in this section, and it's going to be what's known as quadratic form. Now, here's what's going to happen. This one's going to look kind of complicated at first. I promise you it's not complicated at all. This one actually might be the simplest of the factoring methods we've looked at so far. And here's what we're going to do. You're going to take a polynomial that is not in quadratic form, and we're going to kind of do a little bit of substitution to help us get it into quadratic form. So what this is, quadratic form can be written as, and you should recognize the quadratic form from chapter 4. We spent a ton of time on quadratics. You know that quadratic form is whenever the term of the highest degree is squared, right? So I have a, u squared, a, b, and c are just constants, right? They're coefficients, they're going to be some number. U is my variable, right? U is my variable. I have a u squared, that's what makes it quadratic. I have a u to the first, that's my linear term, and then my constant. So you should recognize this form. We just would have used x's back in chapter 4 instead. Little typo here. Not n, we're not using n's, there's no n in there, it's actually a u. And what you guys are going to do is you want to get this expression, which is in x, and rewrite it, right? You'll be given some expression in x, we're going to rewrite it using u so that I wind up with a u squared here, which gets it into quadratic form. So let me show you how this works. All right, I've given you a polynomial that is x to the 8th. That is definitely not quadratic. This would have to be squared in order for it to be quadratic. But what you recognize is that using properties of exponents, x to the 8th can be rewritten as that is x to the 8th is equal to x to the 4th squared, right? This is the power property of exponents, which says if you have something raised to a power, you multiply those exponents together. So 8 is simply an x to the 4th raised to the second power, which is exactly what I've done right here. I've used that power property of exponents to rewrite this as 6 times x to the 4th raised to the second power. Now, why that works is because I already have an x to the 4th in the problem, right? You were given an x to the 4th right here, and so now these guys inside parentheses are exactly the same, and they have to be, right? You need both of the quantities inside the parentheses to be the very same variable raised to the same power, because we're going to do a u substitution, right? We're going to substitute in a u everywhere I have an x to the 4th. Well, I have an x to the 4th right there, so I'm going to replace it with a u, and I now have a u squared, quadratic form. X to the 4th, so I have an x to the 4th right here. I replace it with a u. That leaves me with a u right there, and what you guys now have is this looks like our quadratic form, where my biggest term, has a degree of 2. All right, so that's what we're going to do in all these problems. Let's go ahead and take a look at a couple of examples and see how this is going to work. All right, I take a look at this guy, and I recognize that, first of all, what you should see, 150, 40, and 15, I have a GCF of 5. So I'm going to go ahead and pull out that GCF of, I believe so, I should be able to pull out a 5. Let me double check and make sure. Yeah, okay, so I'm going to pull out a GCF of 5. And that's going to leave me with a 30 n to the 8th plus 40. Pull out a 5, that's going to be an 8. And minus 15, pull out a 5, that leaves you with a minus 3. Okay, so I pulled out my GCF. And now what you'll get used to recognizing as we go through these problems is this. This n to the 8th and the n to the 4th. Well, I can rewrite n to the 8th as n to the 4th squared. So 5 times the quantity 30, n to the 4th squared, right? Because 4 times 2 gets me 8. And this n to the 4th is what I already have right here. So plus 8 times n to the fourth. And what we said is that these two quantities have to be the same variable raised to the same power, and they are n to the fourth, n to the fourth. So we can do a simple substitution here where we let u be equal to n to the fourth, and that means that I now have 30u squared plus 8u minus 3. Now, why this is helpful, you'll see in a second when we actually set these guys equal to 0 and solve them to find our roots. For now, we're just getting some practice using this factoring method. So there we go. I've rewritten this guy in quadratic form. But guys, it's not always going to work. Like, for example, we take a look at this one, and I recognize right away, well, I don't have a GCF, but this y to the 8th. Hey, I can rewrite that as y to the 4th squared. But the problem is, I don't have a y to the 4th here, I have a y to the 3rd, and these quantities are not the same, which means I cannot use this quadratic form method for factoring this guy, and so what I find is that this is prime. Right? There's no way I can't do a u substitution for both y to the 4th and y cubed, right? U has to be equal to the same value. It either needs to be a y to the 4th and a y to the 4th, or a y cubed and a y cubed inside those parentheses. And since they're not the same, it doesn't work. This method doesn't work, and so I'm left with prime. Let's try a couple more. Let's take a look at this one. X to the 4th, 5x, and x to the 6th. Okay, well, x to the 4th is not quadratic, but I recognize I can rewrite that as an x squared, right? Because 2 times 2 gets me 4. But then what I've got over here is a 5x plus 6. Well, once again, what's inside the parentheses is not the same. This is an x squared, that's an x, and so this quadratic form isn't going to work. This one as well is prime. All right, slide on up, try another one. Ooh, right away I recognize here I should be able to pull a 2 out of these guys. So let's go ahead and see if we can pull a 2 out of here. I pull out a 2, that's going to leave me with 4x to the 4th plus 6x squared plus 9. All right, so I factor out my GCF. Sorry, I wrote x squared, should be x to the 4th. And now I take a look at this guy and go, okay, well, let's see, maybe that quadratic form will work. So I recognize that I can do x to the 4th as an x squared, right? X squared squared, 2 times 2 gets me 4, plus 6x squared. Hey, look at that. What's inside the parentheses are the same. So it looks like quadratic form is going to work for me, where u is going to be equal to an x squared. So I just substitute that in. And there we go. I don't need the parentheses anymore, so 2 times 4u squared plus 6u plus 9. And again, what we'll do is you'll see here in a second, when I set this guy equal to 0, I should then be able to keep going to factor this guy out and find my zeros. But for now, like I said, we're just getting practice writing these polynomials in quadratic form if you can. I think I have one more example here. We'll try this one, see how it goes. Again, just taking a quick look at it, I recognize I have a GCF. So make sure you pull that GCF out. It looks like I can pull out a 2. That's going to leave me with a 5x to the 6th minus 6x cubed plus 7. And then I recognize this x to the 6th. Well, I actually can rewrite that using that power property. I can rewrite it as an x cubed squared, right? Because 3 times 2 gets me 6, and this x cubed is exactly what I was given right here. So now, what's inside parentheses is the same. Quadratic form is going to work, where u is equal to an x cubed. Go ahead and substitute that in. So now I have a 5u squared minus 6u plus 7. And I've rewritten that polynomial after pulling out a GCF in quadratic form. This is very, very important. Don't forget this. Don't leave this out. Don't lose it. Later on, when we get to factoring these here in a second, you'll see why it's really important that you remember that. But that's just some practice writing polynomials in quadratic form. Now, on the next page of notes, what we're going to do is actually use these methods to find the zeros of these polynomials, meaning we are going all the way to our actual solutions. Our roots are zeros. Where do these polynomials cross the x-axis? So head on over to the next page of the notes, and I'll meet you guys there.